Hi, everybody in Econ land. This is a review of assignment 1 for Econ 1B. People had some questions about a couple of the problems, so I'm going to go through all of them. And hopefully that will clear up any confusion, any questions, any concerns, anything like that. I have also posted an answer key onto Canvas, so check that out. It's got a lot of details. Let me know any questions you might still have. So, Assignment 1 looks at trade-offs. It looks at gains from trade. It looks at the production possibilities frontier, and it looks at comparative advantage. Remember, comparative advantage is the ability to produce something at the lowest opportunity cost, not the lowest explicit cost. Problem 1 talks about applying that to your own personal life. So it says, give an example of a trade-off you faced in your life. What decision did you make, and what was the opportunity cost of that decision? So me, for my life, just today, I actually went out to eat a meal recently, and which was pretty exciting in a time of COVID. And I had to make a decision about what to order. And there were two things I wanted to order. I wanted to order either the chilaquiles or the ceviche. And it's a great example because that's my trade-off, right? I had to decide between picking one of those two meals. I picked the chilaquiles, and that means my opportunity cost was the ceviche. And this is a nice example because I still had to pay an explicit cost, a dollar value for that meal, right? I had to pay the restaurant for the food. So there was a cost associated with it, but there's also the opportunity cost. So what I gave up was ceviche in order to have chilaquiles. And so that's a great example, in my opinion, because there's an explicit cost, right? The dollars it takes for me to make to buy ceviche. And then there's the opportunity cost, what I gave up to get it, what my next best option was. A lot of people talked about the trade-off between work and school. So if you're going to school, you're giving up an hourly wage every hour you spend at school, or sleeping versus studying. And those are all great examples. You always want to just think about the opportunity cost as being the value or whatever your next best option was. So problem number 2 looks at the two cities. We have the city of Boston and the city of Chicago, and they are both producing socks. And this one's a little bit different than what we've looked at before because of the way it's phrased, right? So what we're looking at is the production of red socks and white socks. So I've got pairs of red socks and pairs of white socks. And it's how many each city can produce in a given hour. So for the city of Boston, they can produce 3 pairs of red socks in an hour. And the city of Chicago can produce 5 pairs in an hour. And the city of Boston can produce 6 white socks per hour. 6 pairs of white socks in an hour, and Chicago can produce 4 pairs of white socks in an hour. And if that's not a great way or an easy way for you to think about it, you can also think about it as being in terms of fractions of an hour. I'm going to try and make this a little bit easier to see. Hopefully that pen's a little bit. Y'all know how I like my colored pens. So we can also think of it as being, okay, well, in an hour, Chicago produces 5 pairs of red socks, or each pair of red socks takes 1/5 of an hour per pair. For Boston, it'd be 1/3 of an hour per pair. And then they'd only need 1/6 of an hour. A 1/6 of an hour to produce a pair of white socks, and Chicago only needs 1/4 of an hour to produce a pair of white socks. So that's another way to look at it, and then you can use our relationship of, okay, if I want to find the opportunity cost of producing red socks in Boston, I'm going to divide the cost 1/3 of an hour to produce a pair by the cost of producing a pair of white socks 1/6 of an hour to get that opportunity cost in terms of the number of white socks, the pairs of white socks given up. So you can calculate it mathematically. I talk about it in the answer key. I talked about it in the other video I posted on YouTube. or you can talk about it theoretically. And for a problem like this, where it's set up not in explicit costs, but in how many you can produce in an hour, which is a little bit weird, I think it's easier to think about it intuitively. So if we're looking at Boston and we're trying to find the opportunity cost of a pair of White Sox, so write that up there. In an hour, Boston can produce 6 pairs of White Sox or 3 pairs of Red Sox. So that means that they can produce twice as many White Sox as they can Red Sox. So in the time it takes to produce a pair of White Sox, they could produce half of a pair of Red Sox. Or if it's easier, and this is why I put both of them in here, think about it the other way. If it takes an hour to produce 3 pairs of Red Sox, how many pairs of White Sox do you have to give up? Well, if you could produce 3 pair in an hour or 6 pair of white in an hour, that means that every time you produce a pair of Red Sox, you're going to give up twice as many White Sox, because you can produce twice as many White Sox in an hour as you can Red Sox. So that means that the opportunity cost of Red Sox is 2 pairs of White Sox. And the inverse is going to be true for White Sox. If the opportunity cost of Red Sox is 2 White Sox, the opportunity cost of White Sox is 1/2 a pair of Red Sox. So sometimes if you like to do it intellectually, intuitively, and think about what's given up to get rather than calculating it mathematically, you can start with the direction or the opportunity cost that makes the most sense logically, right? If we're looking at Chicago's opportunity cost of opportunity cost of White Sox, we can say, okay, well, if we've got Chicago's opportunity cost of White Sox, we can set it equal to the cost 1/4 hour per pair of a pair of White Sox divided by 1/5 of an hour per pair for Red Sox, and get 1/4 divided by 1/5 gives us, or 0.25 divided by 0.2 gives us 1 1/4 or 1.25. So that's going to be 5/4 of a pair of Red Sox. And you can kind of see it if you have a really mathematical mind, and this is fun for you. You can see how if we go through, we have the White Sox will cancel out, and that's how we get left with Red Sox as our term, as our units for this one. So you can also think about it intuitively. If we could have produced 5 pairs of Red Sox in an hour or 4 pairs of White Sox in an hour, then in the fraction of time that it would have taken to make a pair of Red Sox, we couldn't have produced a whole pair of Red Sox, right? In the fifth of an hour it takes to produce a pair of Red Sox, we would have gotten close to, but not completely done with, producing a pair of White Sox. And so the opportunity cost there is going to be 4/5. So the opportunity cost of a pair of Red Sox is 4/5 of a pair of white, and the opportunity cost of a pair of White Sox is 5/4 of a pair of red. And then once you've done your calculations and gotten your opportunity cost, figuring out comparative advantage is pretty straightforward, right? Absolute advantage is simple. Comparative advantage is pretty straightforward too. So if we want to know who's the best in terms of absolute cost at producing Red Sox, well, Boston can produce 3 pair in an hour and Chicago can produce 5. That's more. Their cost, 1/5 of an hour, is lower. If we're looking at producing White Sox, Boston can produce 6 pairs in an hour. Chicago only produces 6. Chicago has a price of 1/4 an hour, and Chicago has a price of 1/6 of an hour. So Boston has a price of 1/6 of an hour, so Boston has the absolute advantage. Comparative advantage is going to look at that lowest opportunity cost. So if we look at who has the lowest opportunity cost in terms of White Sox, Boston gives up half a pair of Red Sox. Chicago gives up a pair and a quarter of Red Sox. So again, Boston has, oh, that pen doesn't work at all. Boston has the comparative advantage in producing White Sox as well. And if we look at Red Sox, Boston has an opportunity cost of 2 White Sox to produce a pair of red. Chicago has an opportunity cost of 4/5 of a pair of White Sox to produce a pair of red. So they also have the comparative advantage in producing Red Sox. Make sense? Hopefully. All right. The next problem is the Pat and Kris problem. So Pat and Kris are roommates. They spend a lot of time making root beer and pizza when they're not studying and working. They each have 18 hours to produce. Is that right? They have 18 hours to spend making either pizza or root beer. For Pat, each pizza costs 2 hours, and each gallon of root beer costs 4 hours. Right? Yeah. For Kris, each pizza takes 4 hours, and each gallon of root beer takes 6 hours. So if you want to build a table, it's an easy way to get all of the different production possibilities, or at least give you a couple of points to graph. On the answer key, I go through and do a lot of iterations. Remember, in economics, we think about marginal thinking. We make decisions on the margin. So you can think about making, say, one pizza. If Kris makes one pizza, that's going to take 4 hours out of 18 hours total. That means that Kris will only have, if Kris spends 4 hours making pizza, they will only have 14 hours left to make root beer. And in those 14 hours, they can make 2 1/3 gallons of root beer, right? So you can use fractions here, and it's totally fine because economics allows for it because of that marginal thinking, because we talked about rational people making decisions on the margin. For our purposes, I'm going to kind of keep it simple, and I'm going to say, okay, we've got Kris and Pat, and I'm going to give a couple of options for pizza and root beer for both of them. So, okay, so Pat can either spend all of their time making pizza. And if Pat spends all of their time making pizza, they've got 18 hours to make pizza. It takes 2 hours to make each pizza, so that would be 9 pizzas and 0 gallons of root beer. If Pat spends all of their time making root beer instead of pizza, they'll make 0 pizzas. And in 18 hours, at 4 hours a gallon, Pat can make 4.5 gallons of root beer. And then let's pick one more kind of midpoint. What if Pat makes, if Pat spends 6 hours making pizza, that'll be 2 hours per pizza, meaning that Pat will make 3 pizzas. And that's going to take, so if Pat makes 3 pizzas at 2 hours per pizza, that's going to be 6 hours for pizza. That's going to leave 12 hours for making root beer. 12 hours with 4 hours per each gallon is going to mean that Pat can make 3 gallons of root beer. On the other hand, if Kris only makes pizza, then Kris is going to spend 4 hours making each of those pizzas in a total of 18 hours. 18 divided by 4 hours for each pizza means that Kris could focus on only making pizza and make 4.5 pizzas and 0 root beer. If Kris only makes root beer, it takes 6 hours to make each gallon of root beer. 18 hours divided by 6 hours per gallon of root beer is going to mean that Kris can make 3 gallons of root beer and 0 pizzas. Or Kris can split the difference and, let's say, make 2 gallons of root beer. Those 2 gallons of root beer would take 12 hours. So there's 2 gallons of root beer. 18 hours minus those 12 hours is going to give us 6 hours left to make pizza. In that time, Kris can make 1 whole pizza and another half, right? So if Kris chooses to make 2 gallons of root beer, they can also make 1.5 pizzas. Cool, so far so good. So there's a lot of combinations. Pick a couple, explain a couple of different combinations, and then we want to graph Pat's production possibilities frontier with respect to producing pizza and root beer. So now I'm going to erase that stuff and go ahead and put my axis up. And it doesn't matter for our purposes whether you put root beer on the y-axis or the x-axis, and on the pizza up here. And I just want to look at what Pat's production possibilities are. And so I've got a couple here. I said Pat can produce 9 pizzas and 0 gallons of root beer. Let's say that's 6. That would make that 3. And then Pat can also produce 3 gallons of root beer, 0 gallons of root beer, or 4.5 gallons of root beer, right? So now I can draw my production possibilities frontier for Pat. I want to connect this endpoint here of all pizza production to this other endpoint of all root beer production. Cool? That's a production possibilities frontier. Any point along this production possibilities frontier is going to be possible and efficient for Pat. The PPF represents all the possible production combinations. Now we want to know the opportunity cost of making pizza for both Kris and Pat, and then who has the absolute advantage and the comparative advantage. So we have their explicit costs here. Let's make a new table and look at their opportunity costs. So we've got pizza and root beer. And we have Pat and Kris. I'm still in frame here, more or less. So Pat and Kris have each their own opportunity cost of pizza and root beer, and it's going to be in terms of the other good. So Pat's opportunity cost of pizza is going to be based on how much root beer is given up to make that pizza. If Pat can make a pizza in 2 hours or a gallon of root beer in 4 hours, in the 2 hours it takes to make a pizza, how much root beer could Pat have made? So in the 2 hours it takes to make a pizza, let's say we have 1 hour, and here's 2 hours. That would make 1 whole pizza for Pat. But if Pat wants to make a gallon of root beer, Pat has to use 4 hours. Another hour here and another hour here. So that would be how much time it takes for Pat to make root beer, 4 hours. In the time it takes Pat to make a single pizza, Pat can't make a whole gallon of root beer. In fact, if it takes 4 hours to make a gallon of root beer, in the 2 hours it takes to make pizza, Pat can only get halfway through that gallon of root beer. So the opportunity cost of pizza is 1/2 gallon of root beer. Does that kind of make sense? So I'll go ahead and put that in here. Opportunity cost of pizza for Pat is 1/2 gallon of root beer. And we can do the same thing and kind of step back and do the same thing looking at the opportunity cost of root beer, right? So if Pat can make a gallon of root beer in 4 hours, right? How many pizzas does Pat give up? Well, in the first 2 hours, Pat gives up 1 pizza. In the next 2 hours, Pat gives up another pizza. So the opportunity cost of root beer is 2 pizzas. Does that kind of make sense? This is a weird concept. Opportunity cost is hard. Comparative advantage is hard. So I hope that by showing you a couple of different ways to think about it, it makes it easier to process. So we got opportunity cost of pizza is 1/2 gallon of root beer. Opportunity cost of root beer for Pat is 2 pizzas. We can also calculate it mathematically and say, okay, if we wanted to find the opportunity cost for Kris in terms of making pizza, so the opportunity cost for Kris of making pizza is equal to the cost associated with making pizza, 4 hours, divided by the cost associated with making root beer, 6 hours, which gives us, this is going to be 6 hours for pizza and 4 hours for root beer. That's going to give us our opportunity cost of pizza is going to be 4 divided by 6, or Kris's opportunity cost of pizza is going to be 2/3 of a gallon of root beer. And that's because you can see again here, the 2 pizzas cancel out, the hours cancel out, and all we're left with is 2/3 of a gallon of root beer. Does that kind of make sense? So Kris's opportunity cost of pizza is 2/3 of a gallon of root beer. And the inverse is going to be true. The opportunity cost of producing a gallon of root beer is going to be 3/2 or 1.5 pizzas. And again, you can think about it this intuitive way, which I like. I think it's kind of fun. So maybe I could say, okay, in the time it takes 6 hours to make a gallon of root beer. So there's 1, 2, 3, 4, 5, 6 hours. So in that time, if Kris wanted to make, in the 6 hours it would take to make a root beer, if Kris wanted to make a pizza, it would take 4 hours to make 1 pizza. And then there would be 2 hours left. We can't make a whole pizza in those 2 hours, but we can make half a pizza. Okay? So hopefully that helps make it make sense. So now Kris's opportunity cost of root beer is 3/2 of a pizza, or 1 1/2 pizzas. And then to find the comparative advantage and absolute advantage, one more time, we look at, for absolute advantage, who has the lowest absolute cost. So in terms of making pizza, it takes Pat 2 hours, Kris 4 hours. So Pat has the absolute advantage. 2 hours is less time than 4 hours. When it comes to making root beer, Pat only needs 4 hours. Kris needs 6 hours. So Pat also has the absolute advantage in producing root beer. If we want to look at opportunity cost, we say, okay, Pat gives up 1/2 gallon of root beer. Kris gives up 2/3 a gallon of root beer. Half is less than 2/3. So Pat has the comparative advantage in making pizza. And when it comes to making root beer, Pat gives up 2 pizzas, but Kris only gives up a pizza and a half. So now Kris has the comparative advantage in producing pizza. Cool? I'm sorry. Kris has the comparative advantage in producing root beer because Kris only gives up 1.5 pizzas. Cool? So Last problem is the China and US example. China and the US each have 1 million workers and can produce either computers or shirts. In a year, a US worker can produce 60 shirts. Let's do it this way. In a year, a US worker can produce 60 shirts or 30 computers. A Chinese worker can produce in that same year 60 shirts or 12 computers. Right? There are 1 million workers in each country, so graph the production possibilities frontier for the China and the US. This is pretty straightforward. I think a lot of people got stuck on this because they started to overthink it. So let's just look at what that means. Okay, so the US can either produce shirts or computers. And each worker can produce 60 shirts or 30 computers. There are 1 million workers. So if all 1 million workers produced computers, that would be 30 million computers. If all 1 million workers only produced shirts, that would be 60 million shirts. So that gives us a production possibilities frontier that we're super comfortable with and can totally graph, right? That's just a trade-off between producing all shirts or all computers. Cool? Straightforward? You could also say, okay, well, what if 50 million workers produced shirts? It'd be 50 million times 60. What if 50 million workers produced computers? You'd get half of each, right? So that's the US's production possibilities frontier. Same thing for China. China can produce either computers or shirts. If all 1 million of China's workers produce shirts, they will also produce, and I'm going to kind of try and make it work here, 60 million shirts. But if all of China's workers produce computers, they can only produce 12 computers in a year. So all 1 million workers would only be able to produce 12 million computers. That gives us China's production possibilities frontier. I'm going to do it in a different color because I like colors. So all the workers can either produce shirts or computers or any combination of the two, right? So part B says, suppose each country spends half their time producing each good. Indicate on the production possibilities frontier the consumption point without trade. So now we want to say, okay, if the US sends 500,000 workers, 500,000 workers to produce shirts, they'll make half as many shirts, or 30 million shirts. The other 500,000 workers are going to make computers. They can each make 30 computers. That's going to give us a total of 15 million computers. So that's going to be our production point. In China, those same 500,000 workers, half of the working force, is going to still produce that same 30 million shirts. Oops. But those remaining 500,000 workers are only going to be able to produce 12 computers each. So 12 computers times 500,000 workers means that we'll only get 6 million computers. So that gives us our production point for China and our consumption point for China. If the countries were to open up to trade, who would export shirts and who would benefit from trade? To figure out who's going to export shirts, we have to find the comparative advantage in shirts. Oh my gosh, we have to calculate comparative advantage one last time. So if each worker in China could produce 60 shirts in a year, or 12 computers in a year, how many computers does a Chinese worker give up when they produce a shirt? So we can think about this intuitively, we can calculate it mathematically. What you want to think about is, okay, if it takes, and again, you can do the same thing you did with the socks problem and say, okay, each shirt takes 1/60th of a year to make, and each computer takes 1/12th of a year to make. Right? So in the 1/60th of a year that it takes to make a shirt, how many 1/12th of a year computers could a Chinese worker make? Well, they won't be able to make a whole computer. They'll only be able to make a fraction of a computer, and it's going to be a small fraction of a computer, right? So we can do this by calculating it. You can do it intuitively. You can do it however you want. I'm going to calculate it just one last time. So if we want the opportunity cost of a shirt, we need to look at the cost of a shirt, 1/60th of a year, and the cost of a computer, which is 1/12th of a year. And that's going to give us the opportunity cost of shirts in terms of computers, which is going to be 1/5 of a computer. And we can double check our math, right? So we can think about in the time it takes to make a shirt, how much of a computer we can make. We can also flip it and say, okay, in the 1/12th of a year that it takes to make a computer, how many shirts could we make? And if you look at that, you can see that it's going to mean that you could make a shirt 5 times in the time it takes to make a computer, or it takes 5 1/60ths to make a 1/12th. So we have our opportunity cost of making a shirt in China is going to be 1/5 of a computer. And then we just need to find the opportunity cost of making a shirt in the United States. In the United States, a shirt takes, a worker makes 60 shirts in a year or 30 computers. That's easy, right? We can look at it here on the graph. That's another way we can think about opportunity cost. If we shift a worker from making shirts to computers, we're going to move down this slope. We're going to go from here at 60 million shirts and 0 computers to 1 fewer shirt, right? 49 million shirts, or 1 fewer shirt and some fraction more of computers. And so we can think about the slope of this production possibilities frontier giving us the answer. And we can see that it's a 2-to-1 relationship, right? You can make twice as many shirts as you can computers. So if we give up a shirt, we're going to get half of a computer back. Or in the time it takes to make a computer, a worker could make twice as many shirts. So that means that the opportunity cost of making a shirt in the United States is 1/2 of a computer. And that tells us that China has the comparative advantage in producing shirts. They give up fewer computers when they make shirts than the US does, even though the US has the absolute advantage in making computers. Cool? Finally, who would benefit from trade? Both countries would benefit from trade because everyone can benefit from trade because trade helps make everyone better off. Cool? All right. The next video I'll post in a little while is going to look at another way of putting together a review problem for looking at the market forces of supply and demand. So keep an eye out on that. Otherwise, have a great day, be well, and let me know what questions you have. Okay, take care.